So we have a user, Kenobi, who has asked how to draw an n-gon. You just give the number of sides. He says prism, but I don't think I asked if he needs 2D or 3D. So we'll see what he says, but I hope it's not 3D, because that's much harder. Anyways, there's a few patterns. What I've done is just drawn out the basic n-gons: triangle, square, pentagon, hexagon, heptagon, octagon. And I've given them all a base length of 75, and I've, through math, just calculated out the, basically if you were to start the object with that line and then draw another line, a different length, and another line. And again, these are just lines they're not really lines, they're rectangles of 1 pixel in height, because computer screens only go up to a pixel, so we don't have to worry about anything less than that. Eventually you get a triangle, or if you did it and you kept it all the same length the whole time, you get a square. I can't draw too well, but you get my point. So you can basically generate any shape just by drawing a bunch of lines, which is I actually can't recall the word for it right now, but I know that's how either Illustrator or Fireworks, one of those two, works that way. And it's great because you can scale it to you can scale the image to any size you want, as long as the math data is there. In our case, the lines you can just calculate, and well, we'll get into that. Anyways, I've split the n-gons. On the left side we have our odd numbered, so 3, 5, this is just the number of sides, 3 sides, 5 sides, 7 sides, and here we have 4, 6, and 8. So the base length on all these is 75. On all of the odd numbered gons, it's going to go from 75 to something, 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 whatever, to 0, meaning they all end in a point, whereas all of our even gon numbers start and end with 75. They all have bases. Boom, boom, boom. Okay. So another pattern you can recognize with even gons is that they're always every other even gon. So this one has it, this one doesn't, but then the every other, the next one will, is that yes, they both start and end with the same length base, the top and bottom, and then they also have the next section will be mirrored. So basically what I'm just saying is they're symmetric in 2 ways. Well, that's not actually what I'm saying, because that applies for this too. They're more symmetric, meaning that they don't have a point they're split on, but they're actually split in the middle of a side. 2 90-degree angles with equal side lengths. This one is true, but it's 0. Anyways, you can see what I'm saying when I draw these brackets. So, to draw any shape, you need to calculate the length of these sections here. And the way I've done that is by solving the interior angle, meaning this angle, which is the formula for n-gons. I'll go ahead and pull that up. (180 times n minus 2 over n, where n is just the number of sides in your gon. And you'll subtract, well, it alternate. You subtract 90 up until the very last one if you need it, which you don't, except for every other odd gon. But anyways, you subtract 90 because we have our whole interior angle, which is, let's just say for the sake of example, this formula with a pentagon should return 4, 3 divided by 3 is 87, 108. Let me just, I don't trust my head math. Let's just calculate it real quick with Wolfram Alpha. Mathematica. Okay, 108 degrees. So basically 108, and then I subtract 90 degrees to get me this angle right here. So that's going to be 18 degrees. And I know that this length here, since it's a side, and n-gons always have the same side, since I know that my base is, say, 75, then I know that this length is 75-ish. So I use the sine, this is just the trigonometric identities, the sine of 18 degrees, which is this, is equal to this length, this length up here divided by this length. So if we multiply by our n, in this case 75, over the sine of whatever that formula was to get the interior angle minus 90, in our case 18, and again that's not supposed to be minus, that's supposed to be times. I'm going to do 75 because that's what we're working with. For example, 75 times the sine of 18 is equal to this length up here, and we need that length twice, 2 plus 75 will get us the full length of what our lines are going to be growing to when we're drawing our our 1 pixel high lines to draw this shape, to draw our little pentagon. And this is a poor example, but because I can't draw that well, but you see it, right? Anyways, to calculate that, we do need the length of this center part here, which I'm figuring out. Real quick, there's always just another pattern that'll make it easier for you to create the program to draw it. Every time you switch back to the odd side, the amount of lines or defined lines increases by 1. What I mean by that is we start at 75 and we go to 0, so that's just 2 numbers given. And then we start at 75 and go to 75. And then we go back to the odd side, so it increases by 1. 75, and then we go to a second line, and then we go to 0, so now there's 3, and then there's 3 again. And then we go back to the odd side, so now there's 4, and it goes here, and it goes to the biggest line, and then the second biggest line, and then back to 0. And then here it's the same thing. And we know that these two will be the same number, as well as with every other n-gon. These central two will be the same. Anyways, back to this, 75 times sine of 18 degrees, that whole thing times 2, because that's whatever, that'll just give us this length up here, and we have 2 of those lengths, and then plus whatever this side was, because we're just translating that, we're just translating that up to here, and then adding it to those 2, so again, 75, you just plug in your side, your n, I'm sorry, not your n, the length of your n. So 75 plus 2 times 75 times the sine of 18 gets us that, which is approximately 121. I already calculated it out. And the only other thing, so now you know you have your variable. We have our base of 75, and then we're going to 121, and then since it's an odd numbered gon, and it's 5 to be specific, we're on the 3 numbers, so we know the next one is 0, and because it's odd, we know it's 0. If it was even, and it was like a hexagon, since that's 6 divided by 2 is 3, so that's where we're getting how many numbers, by the way. You just go to the closest next highest even number, so 5, the next highest even number is 6, and 6 divided by 2 is 3, which tells you that we're going to have 3 lines. Or if you're on 6, you're already on 6, so it's already even, so you just divide it by 2, 3. We're going to have 3 lines. And if it's odd, you go to 0. And if it's even, you go to whatever the length of your base is, in our case 75. And this middle line will be different. If it's odd, that's going to be a different length than when it's even. I'm assuming. I haven't calculated it out, actually, but either way, you can calculate it pretty quickly with this formula I've given you here. And the ratio is going to be consistent for these next ones, you can see that this triangle here is 1/3 of this triangle, which is, or 2/3, which is 1/3 of this triangle. You see it decreases each time, so you can calculate all that as well. You now just need to know the height of the whole thing, which you can also calculate with basic geometry. For the sake of keeping this video short, I won't go into it. But for now, we can just say real quick, if the sine gave us this height, the sine of 18, 75 times the sine of 18, then when we want to solve for the adjacent side, we can use the cosine. Sorry, it's been a while since I've been in trigonometry. Hold on. Cosine. Yes, okay, so the hypotenuse, the 75, the length of your side, times the cosine of whatever that degree was, minus the interior angle degree minus 90, in our case 18. So 75 times the cosine of 18 will give you the height, which tells you the height of this. Therefore, when you're drawing your lines and you start with 75 and you know that each line by definition has to be 1 pixel high, you figure out that when we have the height, oh, the height is 15 pixels tall, and we'll say 70 pixels tall, and we have 75 pixels for our base. So each time we draw a line that's 1 pixel in height, it's going to increase, and what you're just going to do is whatever 121 from 75 to 121 over a length of 70 pixels. You just figure out how much it increases based on that. So 121 minus 75, aka the length of this minus the length of this, divided by the height in between those two, in our case 70 pixels, or I haven't actually, let me actually calculate it just so you can draw an accurate pentagon. 75 times the cosine of 18 degrees, make sure you do degrees, not radians. Wow, I was really close. 71. Okay, so 71 pixels in here. So the length of this minus the length of this, giving you the change in length, the total change in length, over a period of 71 pixels. So we're going to, 46 is the length of that minus the length of that, divided by 71. For every new line you draw, the length of the line increases by 0.647. We'll just do 0.65 until you get to your final line here, which will be 121 in length. And when you do that and you center the line each time, meaning when you're drawing your little rectangle that's 1 pixel high, and whatever you calculate it, whatever the previous one it was, plus 0.647, it will simply, meaning that rectangle is centered on this the center of your n-gon, where the point of the top is if you're odd, or the center of the base is if you're even. When you draw those lines, you will eventually get a fill. That is how things are filled. You're just filling in all the pixels on the computer because you're drawing so many lines that are filling up all the pixels. You will get a fill. And then you can, again, you just calculate using the patterns I've shown you, the height from that line to whatever your point is, which in our case this is an odd n-gon, so it'll be a point of 0, and you draw the lines and you know the width of the line, how much it's going to decrease just by doing that formula again, and you will get a fill, and you'll eventually end up with a great pentagon. And you can do that for any of these. All the formulas you need are in this video, so just rewind if you need to find something like the interior angle formula and whatnot. And to do things like rotating, I would just stick the whole thing inside one view, nest it, and then rotate that view to get your rotated pentagons or whatever you want. Okay, hope this helped. Let me just go back and make sure you didn't want a 3D object. You haven't responded, so I'm just going to assume this is what you're looking for. Alright, God bless. Bye.